Hello. The term SQL comes from structured query language. A query language is a type of programming language that has been designed to facilitate the communication and processing of information in databases. In a simple concept, SQL is the language of databases. Most companies store their information in databases, and these databases are divided into two categories. We have relational and non-relational databases. MySQL being a type of relational database. Relational databases can be of several kinds. As I said, we have MySQL, and we also have PostgreSQL, Microsoft SQL, Oracle DB, and so on. Most of these databases use the SQL language, so once we learn the basics of this language, we will be able to work with almost any type of relational database. A relational database is a database that stores related information in several tables and allows information to be traversed in more than one table in the same search. It is easier to understand how this concept works by thinking about the following example. Let's imagine that we are a company that wants to keep track of the sales. We could create an Excel spreadsheet with all the information we want to follow in the form of various columns. We can have an order number, an order date, amount due, tracking number, customer name, customer address, phone number, and so on. We can see that in this way, in our Excel spreadsheet, we have the data of two entities. We have both our order data and our customer data. When a customer places more than one order, his data will be repeated for each order, which is costly both in terms of memory and in a possible speed of information processing. With a relational database, like the one in the diagram below, we will avoid all these possible problems. We will be able to create two tables, one for orders and one for our customers. Our customer table will contain a customer ID, a unique identifier for each customer, along with his name, address, and phone number. Our orders will include a unique identifier as well, a date, an amount due, a tracking number, and instead of having a separate field for each type of data of our customer, we will have its unique ID, this being a reference to our customer table. In order to run a database locally, we will need two things: locally installing a MySQL server and installing a tool to browse our databases, namely MySQL Workbench. In the next video, we will install these programs. Hello, in this video we will talk about databases. A database is made up of several tables. Tables are places where information can be stored. Each table will store in its certain type of information. We can have tables in which to store the data of our products, customers, employees, and so on. When we installed MySQL Server and MySQL Workbench, we installed, as the name suggests, a server in which our database will be stored, and any server will always run on a host and a port. In your career, you will reach a point where the servers you work on will no longer be yours. They will belong to the company or the client, and it will be stored on their computers. Now, to learn the SQL language, I started a local server, and any local server will always run on the local host. Also, MySQL databases, whether they are your local databases or someone else's databases, will always run on port 3306. This is the universal value of the MySQL port. Also, to enter a database, there is also the possibility of authentication. You can log in or not. There is no case in the industry where the databases do not have authentication credentials. Although there may be a case where the authentication is not required, this will never happen. Therefore, our local server was installed with the root username and the password that everyone chose, without which our connection to the MySQL server will not be possible. So far, I have specified the terms SQL and MySQL. SQL is the language of databases, while MySQL is the server. In the next video, we will find out what tables are. Hello, in this video we will talk about tables. As I said in the previous video, tables are places where we can store information specifically associated with real-life objects, people and areas. A table is made up of rows and columns. Each column represents a certain property of our entries in the table. In the model on your screen, we can see the columns ID, name, designation, salary and skills. Each of these represents the properties of our employees. One row in a table represents an entry. In the picture, we can see 5 entries in our table. The first having the ID 1001, the name John, designation 2, the salary 2000, and the skills .NET and SQL. 1001 John 2 2000 .NET and SQL represents data. And in the next video we will talk about the SQL data types. Hello, in this video we will download MySQL Server and MySQL Workbench and we will install them. We will open a new Chrome tab and write download MySQL. We will enter the first link, the one from mysql.com, and we will scroll down. Here we will click MySQL Community Downloads. We will click on MySQL Installer for Windows, and we will download the second option. We do not have to register here. We can press No Thanks directly. Just start my download. We can right-click Open when done. After downloading, the installation will start automatically. Once the installation window has opened, we will leave the Developer Default button selected here. We will click Next. At this point, when we see all these sections, we will click Execute. Here, we will wait until they are all 100%. This might take a while. Now, when we see all these checks, we will press Next. Here, it failed for me because the Python connector is already installed in my computer. We will press Next, again Next, and here we will not change anything. The port must remain 3306. We will click Next, Next, and at this point we will have to write here a password that we must remember. If we forget it, we will have to install all these things again. Once we see that our password is confirmed, I suggest you write it down on a piece of paper. We will press Next, again Next, and Execute. Next, Finish. We will press Next. Here we will have to write down the password I told you earlier to write it down on a piece of paper. We press Check to see that everything is okay. We will click Next, again Execute, and now we will press Finish. Next, and again Finish. A terminal will open for us that we can ignore. We will close it. Also, MySQL Workbench was opened. This is our tool that we just installed. I already have 3 connections established because it is not the first time I installed MySQL Workbench and the connections remained on my computer. Right now, you probably have only one. In the next video, we will talk about databases. Hello, in this video we will talk about SQL data types. As in Java, we saw that in SQL we will work with information and this information can be of different types. The ones we are going to talk about now are the most common types of data used in SQL. First of all, we have int. The int data type can store, just like in Java, integer numeric values. We have also varchar, which stores text information. This varchar can be associated with the Java string object. When we define a varchar type column, we must also specify something else. You can see on the screen that after the varchar, we have a number inside parentheses. This number represents the number of characters that our table will assign to that column. It is not recommended to define varchar type columns that are larger than the information we are going to store inside them because it is costly in terms of memory. If we know that we are going to create a column in which we will store, for example, an email, we can assign an approximate number of 30 characters. If we know that column will be used to store the gender of a person, it will be advisable to declare a column of type varchar of one position, since the only information that will be stored inside are the characters M or F. If in a varchar type column that has 20 positions aside, we will try to enter a text that has 30 characters, with white spaces included, the text that we are trying to enter will be cut out and only the first 20 characters will be entered. The next type of data is decimal. It can be associated with the double and float Java data types. It stores fractions. This decimal, unlike varchar, will wait inside its parentheses for two numbers separated by commas. The first number represents the total number of digits allocated for the column values, and the second number represents the number of digits after the comma. As an example, if we would like to enter numbers from 0 to 9 with 2 digits after the comma, such as 4.56, in a decimal column, the first declared number in parentheses should be 3. That is the total number of digits. The second number should be equal to 2. That is the total number of digits after the comma. The blob data type will store images, but we will not focus on it on this course. We will also have the date data type, which will store temporal data. This date type is equivalent to our Java local date and date objects, which we will talk about in our advanced Java course. The timestamp data type can also store a certain point in time. This point represents the total number of seconds that have passed since January 1st, 1970 and the present time. Now that we've talked about the most commonly used SQL data types, in the next video we will learn how to create our own database and connect to it, and we will create our first tables. Hello! In this video we will create our first database. After opening the MySQL workbench, we can see a list of our connections. If we click on this plus, a new window will open for you in order to create a new connection. We will call it My First Connection. We will leave it as standard type. At the port section, we will leave the value 3306 as it is, and at the host name we will leave this value, the equivalent IP of the local host. Our username will be root. Let's now press the test connection button. Now MySQL workbench will ask us to enter our password, which we chose when we installed the MySQL server. If you enter the password correctly, we can see that the connection has been established successfully and we can press OK. We click OK again and you can see that my first connection was created. We will click on it and a new window will open. Now that we've connected to our connection, we'll create our first database. Creating a database is done through the create database statement. We will write in capital letters create database and we will give a name to our database. We will call it My First Database. Mandatory, at the end we will write a semicolon. If you want to enlarge this text, you can hold the Ctrl key on the keyboard and scroll from the mouse wheel. To execute this instruction, we will have to hatch it with the mouse and press this lightning button. This is the execute button. We can see that a window will appear below, and here we will have our reports. We can see that our instruction was executed successfully. Let's create a second database. I will call it My Second Database. For this, we will write create database My Second Database, mandatory a semicolon at the end, I will hatch the query with my mouse and press this lightning button again. Again, I can see that my second database has been created. If we try to create an existing database, we will get an error. If we hatch again with the mouse our second instruction, we can press the execute button and now we can see that we have an error. Can't create my second database. Database already exists. So far, we've created two databases on our server. Through the show databases statement, we can see all our created databases. So we will write show databases and put a semicolon at the end. Hatch the query with the mouse and execute it. We can see that here we have a list of our databases stored on our server. I will have more databases here than you because this is not the first time I've worked with MySQL databases on this computer. Instead, in this list, you can see that my second database and my first database is created. At the moment, I have two databases that I can use. Suppose I want to work on my first database. In order to be able to work in that database, I will have to use it. This is done through the use statement. Therefore, I will write the use keyword, the name of my database, my first database. Semicolon at the end. I will execute this instruction and we can see that at this moment I am now using my first database. If you try to use a non-existing database, let's call it my fourth database. I will run this query and I can see that here I have an exception. Unknown database, my fourth database. Now that we are connected to our database, we are going to create a table. The creation of a table is done by the create table statement, after which we will specify the name of our table. In capital letters, we will write create table and specify the table name. Suppose we want to store people in our table. Therefore, our table will be called person. After choosing a name, we will open and close two parentheses and at the end we will put a semicolon. Inside these round parentheses, we will specify, separated by commas, the columns of our table. These will be specified as the column name, which will be one of our choosing. We will leave a white space, after which we will specify the data type, which can be of any known data type that we've discussed in the previous video. Suppose our people that we will store in the person table will have an ID of type int. Therefore, I will write the name of the column, ID. I will write a white space and then I will declare the data type, which is int, in uppercase letters. Now we are going to specify the following column. I will write a comma, move on to the next line, after which I will specify the name of the column. I will write first name. This first name will be a text. Therefore, the data type will be varchar. A name can generally have an average of 20 characters, let's say. Therefore, I will declare a varchar of 20 positions. After the comma, again, I will declare another column that will represent the last name of our persons. The column will be called last name and will also be of type varchar of 20 positions. How can we see all our tables? In order to be able to see the tables in our database, we will have the instruction show tables. This instruction can only be used when we use a specific database. I will write show tables. At the end, semicolon. I will hatch this instruction, execute it, and we can see below that we don't have any tables. Instead, if I run my first query, the create table query, now I will execute again my show tables instruction. Here I will be able to see the person table. To see all the data in our table, we will write the following instruction. We will write select star from the name of our table, which is person. At the end, semicolon. I will hash the query, execute it, and we can see the structure of our table. We currently have no entries in it, so the only thing we will see will be the column names. Let's create another table, in which we will store cars. The cars will have an ID, a brand, and a model. Instead, I want to create this table in my second database. At this time, any query we will run will be executed in the first database, because that's the database that is selected right now. To create our table in the second database, we will have to use the second database. We will write use my second database. Again, I will execute this query, and we can see that now we are using the second database. If I execute the show tables instructions again, we can see that this time we do not have any tables, because our persons table was created in my first database. Now I am using the second. Here we will create another table and we will call it car. We will write create table and we will name our table car. We will open parentheses and we will write a semicolon at the end. Now, in parentheses, we will specify the column names. We will have an ID of type int. We will have a brand of type varchar of 20 positions. We will have a model, again of type varchar of 20 positions. And now we can create our table. We can hatch it with the mouse. Press the execute button and let's show the tables now in the second database. We can see that the car table is now existing here. Let's select everything from the car table. This way we will be able to see our car table structure. We have an ID, a brand and a model. Hello, let's do some exercises. You can see that I have wrote a text in MySQL workbench. This text is underlined in red because its syntax does not represent the SQL language. We can see that the compiler signals this to us. In Java, we can have comments as we saw. We can also have comments in SQL. We will hatch everything with the mouse and we can press Ctrl/. Or if you use a Mac, you can press Command/. In Java, a comment is represented by 2 slashes. In SQL, we have 2 dashes and a pause. Let's read the first exercise. Create the product table to store products. The products will have a numeric type ID, a name and a double type price xx.yz. Pause this video and try, then we will work it out together. We will first create our homework 1 database through the instruction create database homework 1. We will also use it. We can write use homework 1. We can run many queries at once. We can hatch both with the mouse and press execute. We can see that the database was created and now we are also using this database. We created our homework 1 database and used it. Next, we will create a table of products. We will write create table and now we will give a name to our table. We will write product. We will open and close parentheses and at the end we will write a semicolon. These products will have the following columns. We will have an ID of type int. We will have a product p_name. of type varchar of 20 positions, and we will also have a price, p_price, which will be of type decimal. In its parentheses, we will specify the value 4, because the format has 4 digits, and we will write after the comma the value 2, because we have to have 2 digits after the comma. We will hatch our query with the mouse, execute it, and we can see that our table was created. Let's move on to exercise 2. Create a people table to store people. People will have a numeric type ID, a name, a phone number, a date of birth, and a height. Pause this video and try, after which we will solve the exercise together. We will write the statement create table people. Now we will open parentheses and we will write a semicolon at the end. Now we will have to specify the columns inside. We will have an ID of type int, a person underline name, of type varchar, let's say of 20 positions, a person telephone number, which will not be of type int. We will write it as a varchar, because if we enter a number that starts with 0, the 0 will be cut off, just like in Java. We will write varchar of 10. We will also have a person birthday, which will be of type date, and the height, p_height, which will be of type decimal of 3 and 2. Now we can run our query. We can hatch it with a mouse, press execute, and we can see that the people table has been created. Let's run a show tables instruction. We can write show tables, hatch it and execute it, and we can see that these two tables have been created in my homework 1 database. Let's move on to exercise 3. Create a computer table to store computers. Computers will have a brand, a RAM memory, a processor and a price. Pause the video and try, after which we will solve the exercise together. We will write create table computer, and our computer will have the following columns. We will have a brand of type varchar of 20 positions. We will have a RAM memory of type int. We will have a processor of type varchar of 20 and a price of type int. Again, just like the previous exercises, we will hatch everything with the mouse, execute it, and now if we run our show tables instruction again, we can see that each table was created successfully for each exercise. Hello, in this video we will talk about deleting and modifying tables. Deleting a table is done by the drop table command, after which we will specify the name of the table we want to delete. First of all, let's connect to any connection and to any database. Let's for instance connect to the homework 1 database that we created in the previous video. We can see that now we are using it. Let's see if we have an existing table. We will write again the show tables command. We will hatch it and execute it. Here we can see all the tables that we wrote together in the previous video. To delete the product table, we will write the following instruction. We will write drop table, after which we will specify the name of the table we want to delete. That is product. We will hatch the query, execute it, after which we will execute the show tables command again, and we can see that our product table no longer exists. We will also delete the computer table. We will write drop table computer. Again, hatch it with the mouse, execute it. We will show again all our tables, and we can see that the computer table was deleted. If you don't want to press this button every time you want to run a query, you can simply hatch it with the mouse and press at the same time Ctrl Shift Enter. Now I am trying to run again and again this query. You can see that if I want to delete a table which is not existent, I will have an error. Unknown table homework1.product. This table has already been deleted. Changing the structure of a table can consist of two things: adding and deleting columns. Both things are done by the alter table command, after which we will specify the name of the table whose structure we want to modify. After the name of the table, we will choose what exactly we want to do. We will specify if we want to add a column or if we want to delete a column. The add statement will add a new column to our table. It is followed by the name of the new column and its data type. The statement alter table person add column name decimal of 3 and 2, for example, will add a new column in our table person, which will be called column name, and will have a decimal data type in which we can store 3-digit numbers, 2 of which will be after the comma. The drop column statement will delete an existing column from our table. It is followed by the name of the column we want to delete. The alter table person drop column existing column name query will delete our column called existing column name. That is, if the column exists. If it does not exist, our query will throw an error. Let's go back to Workbench. We will open MySQL Workbench and create our person table by writing the following query. We will write create table person. We will open parentheses and a semicolon at the end. Our people will have an ID of type int. We'll have a person name of type varchar of 25 positions. And that is all. Let's create our table. Hatch it with the mouse, execute it, and now we can see that our person table has been created. We can see that once we have created a table called person, if we run a query again to create a table with the same name, we will not be allowed. If I will try to execute this query again, we will have the following message: table person already exists. Let's change the table now. To add to your person table an email, we will write the instruction alter table person add p_email of type varchar of 40 positions. We will execute this query and we can see that it was successful. Let's select everything from our table of people. We will write select star from person, execute the query, and we can see that now we have the ID, the name, and the email. Now let's delete the column name. For that, we will write alter table person drop column, and here we will write the name of the column that we want to delete. I will write p_name. I will execute the query, select everything from my person table again, and now we can see that I only have the ID column and the email column. The name column has been deleted and the email column has been added. Hello, let's do some exercises. First of all, create the database homework2 database and work inside it. For this, we will write the queries create database homework2 database and also use homework2 database. We can hatch both queries with the mouse, execute them, and now we can move on to the first exercise. Create the product table to store products. The products will have a numeric type ID, a name, and a double price. Delete the price column from the table. Pause this video and try, after which we will solve this exercise together. First, we will create our table. We will write create table product, open parenthesis, a semicolon at the end, and our products will have an ID of type int, a product name of type varchar of 30 positions, and a product price of type decimal of 4 and 2. We will create this table and let's select now all its values. We will write select everything from the name of our table product. We will execute the query and we can see that our product table has an ID, a name, and a price. To delete the price column, we will write the statement alter table product, drop column P underline price. We will hatch our query, execute it, and now let's select again everything from our table product. We can see that the price column is now gone. Also, let's completely delete this table. We will write drop table product. We will execute this query and now let's try to select again everything from our product table. We can see that the table homework2 database.product doesn't exist. Let's move on to exercise 2. Create the people table to store people. People will have a numeric type ID, a name, a phone number, a date of birth, and a height. Add a column representing the person's gender, which could be M or F. Also, add a column to represent the person's IQ. Pause this video and try, after which we will solve this exercise together. We will write the query create table people, and this table will have the following columns: an ID of type int, a person name of type varchar of 20 positions, a person telephone number of type varchar of 10 positions, a person birthday of type date, and a person height of type decimal of 4 and 2. Let's create our table, hatch it and execute it. Let's now select everything from the table we just created. We will write select star from people. We can see that we have an ID, a name, telephone number, birthday, and height. Let's add a new column that represents the person's gender. We will write alter table people, add gender varchar of 1. We will execute this query. Again, select everything from people, and now we can see that we also have another column called gender. We will add another column to represent the person's IQ. So we are going to write almost the same query. We will write alter table people, add P underline IQ, which this time will be of type int. Let's execute our query. Again, select everything from people, and we can see that now we have both gender and IQ. Let's completely delete this table. We will write drop table people. Now, if you are trying to execute again this query, select everything from people, which now is a non-existing table, we will have an error. The table people doesn't exist. Let's move on to exercise 3. Create the computer table to store computers. Computers will have a brand, a RAM memory, a processor, and a price. Delete the memory column and the processor column. Add the color and description columns. Pause this video and try, after which we will write the queries together. We will write the query that I wrote in the previous videos. We will have create table computer, which will have the following columns. We will have a brand varchar of 20 positions. We will have a RAM of type int. We will have a processor varchar of 20 and the price of type int. We will create this table, and after that we will select all our columns. For that we will write select all from computer. We will execute this query, and we can see that we have a brand, a RAM, a processor, and a price. Let's delete the RAM and processor columns. We will write alter table computer, drop column RAM. We will also write alter table computer, drop column processor. To duplicate a line of code, you can simply click anywhere on the line and press Ctrl D. So, let's delete both these columns. We will execute the queries, select again everything from the computer table, and now we will only have a brand and a price. Now, let's add two columns. We will write alter table computer, add C underline color. It will be of type varchar of 15. Also, we will add another column, which will be computer description, also of type varchar of 100 positions. We will execute both queries. Now, we will select everything from our computer table, and we can see that we have our initial brand and price, and also we added two more columns, color and description. Let's clean our database by deleting our computer table. Drop table computer. If we now execute the show tables command, we can see that all our tables have also been deleted. Hello! Now that we know how to create tables, how to delete them, and how to change their structure, it's time to learn how to enter data into tables. The insertion of data in the tables is done by the insert into instruction, after which we will specify the name of the table in which we want to insert an entry. After specifying the table name, we will write the values keyword and open the parentheses. Inside these parentheses, we will specify values for all the columns that our table expects in order. The number of values specified in parentheses must be equal with the number of columns in that table, and must also be of the respective data type in order. If we do not meet these conditions, our query will throw an error. Suppose we have a student table, and each student will have an int type ID, a name, an email, and a description. We will have to specify the ID, the name, the email, and the description. For ID, since it's of type int, we will enter a number directly, and after the comma, we will pass values for the following columns. The next column in our case is of varchar type. Therefore, we will have to enter a value in the form of a text. Unlike Java, where our string values must be enclosed in double quotes, in SQL, varchar values must be enclosed in single quotes. This is the complete insertion of a table entry. The insertion can also be done partially for certain columns chosen by us. These must be specified in parentheses after the table name, and the values entered in parentheses after the keyword values must be specified in that order. Using this instruction, a new entry will be added on our student table with values for each column specified in the query. Instead, all columns in the table that were not specified will have the default value, which is null. Let's see an example in Workbench. Let's go back and create a student table. We will write create table student. We will open and close parentheses, write a comma at the end, and inside these parentheses we will specify our columns. We will have an ID of type int. We will have a student first name of type varchar of 20 positions. Also, we will have a student last name. We will have an email of type varchar of 40 positions, and we will also have a grade of type int. Let's go ahead and create our table. Let's also select everything from our table. We will write select star from student. We will hash the query and execute it, and we can see that here we have the columns ID, first name, last name, email, and grades. So let's insert a student. We will write the insert into student instruction, after which we will simply write values. We will open and close parentheses. Here we will have to enter our ID, first name, last name, email, and grade values. The ID will be 1. The name is of text type, so we will pass it between simple quotes. I will write Tudor. The last name is also of type varchar, so I will also write it in simple quotes. The same goes for email. And the grade will be of type int, so I will simply write 9. Let's select our query and run it. You can see that the insert was successful. Now, if we run the query select all from student, we can see that we have an entry with ID 1, first name Tudor, last name Dumitrescu, email tudor@google.com, and grade 9. Let's insert another entry. We will insert a student with ID 2, name Gabriel, and grade 10. We will select the query, execute it, and now if we run the select query again, we can see that we have 2 entries. Suppose we want to insert a student without specifying his grade and email. All you have to do is specify your ID, first name, and last name. So we will write insert into student, open and close parentheses. Inside them, we will specify the columns we want. We want our ID, our first name, our last name, and that is all. We will write values, and inside these parentheses, we will have to enter values for our ID, first name, and last name. We will write 3, N, Marie. We will select our query and execute it. And if we run our select statement again, we can see that we also have an entry with ID 3, the first name N, the last name Marie. The other columns have the default value null. Let's insert a student by specifying only his first name and grade. We will write insert into student. We will specify it as first name and grade. Values, And here we will have a text and a number. Grade 10, name John. Let's also select this query and execute it, and select everything from our student table once again. We can see that we also have John, grade 10, and the other columns are not specified, therefore we have the null value. Hello, let's do some exercises. Create the insert database and work inside it. For this, we will write create database, insert database, and we will also write use insert database. We will run our queries, and we can see that the database was created and now we are using it. Exercise 1. Create the product table to store products. The products will have a numeric type ID, a name and a description. Add 3 products in the table. Pause this video and try, after which we will write the queries together. We will write create table product, and our products will have the following columns. We will have an ID of type int, we will have a product name of type varchar of 20 positions, and a product description also of type varchar of 100 positions. We will run our query and the table was created. We will also write select everything from product. We can see that for now we don't have any entries. So let's add some. We will write insert into product, the name of our table, values, and here we will have to provide an ID, 1, a name, pants, and the description, best pants ever. We will run our query, and now if we select everything from the product table, we can see our pants here. Let's also add 2 more entries. Gloves, warm winter gloves, and the jacket. This is a nice jacket. We will also have ID 2 and 3. We will run these 2 queries, and now let's select everything from product. We can see that we have 3 entries. Exercise 2. Create the student table to store students. Students will have a numeric type ID, a name, a phone number, and an x.yz average. Add 5 students. Pause this video and try, after which we will write the exercise together. We will first write the create table student query. Our students will have an ID of type int, a student name of type varchar of 30 positions, a student telephone number, also of type varchar of 10 positions, and an average of type decimal of 3 and 2. We will run our query, and we will also write select everything from student. This way we can see the structure of our table. Now let's insert 5 entries. We will write insert into student, values, and here I will provide a number, an ID 1, a name Tudor, a telephone number, and an average. I will also do that 4 more times. We will select all our queries and run them. Now, if we select everything from our student table again, we will be able to see all of our 5 students. Exercise 3. Create the computer table to store computers. Computers will have a brand, a RAM memory, a processor, and a price. Add 3 computers in the table, specifying only the brand and processor. Also add 3 computers in the table, specifying only the brand and price columns. Pause this video and try, after which we will solve this exercise together. First, let's create our computer table. We will write create table computer, and our computers will have the following columns. We will have a brand column of type varchar of 20 positions. We will also have a RAM of type int, a processor of type varchar of 10, and the price of type int. We will run our query and execute it. Let's select everything from our computer table. We can see that we don't have nothing inside it. So let's enter some data. We will write insert into computer, and we will have to enter 3 entries by specifying only the brand and processor. So we will open and close some parentheses. We will write the brand column and the processor column, values, open and close parentheses again, and here we will have to provide a value for the brand and one for the processor. I will have an Apple i9 and also an Apple i5 and a Samsung dual core. We will select our queries and execute them. Now we will have to enter 3 more entries by specifying only the brand and price. So we will write insert into computer. Inside the parentheses, we will specify the brand and the price, values, and here we will have to provide a text for the brand and the number for the price. We will do that 3 times. Samsung, HP, and LG. We can see that we have a little typo here. We will correct it and write brand. I will run my queries again. And now let's select everything from computer. We can see that we entered 3 computers by specifying only the brand and processor, and 3 by specifying only the brand and the price. Let's see how many tables we have in our database. We will write show tables. We have a table for each exercise. Let's delete all of them. We will write drop table computer, and we will also do that for our product and our student tables. I will run these queries, show all the tables once again, and here we can see that we cleaned out our database. Hello! From what we have seen so far, the data in our tables can be read by using the select keyword. If we run the select all from query on our table name, we will return all the entries in our table, and each entry will have all the columns present. There is another option. We can make a more restricted selection in which we can return only certain details of our entries. Suppose we have a student table which has a first name, a last name, and an age. We will run the following query. Create table student, and our students will have the following properties. We will have a student first name of type varchar of 20 positions. We will have a student last name also of varchar of 20 positions, and we will have a student age. It will be of type int. We will create our table and let's enter two values. We will write insert into student values, and here we will provide a text, and a number. We will do that 2 times. Student1 fn, student1 ln. We will do the same for the second student. We will run these 2 queries and let's select everything from our student table. As we know, we will write select star from student, the name of our table. All students will be returned to us and each student will have a first name, a last name and an age. That is all the columns. Now, suppose we are only interested in the first name and the age of my students, not the last name. For this, I will be able to execute the next query. I will write select the name of my column as first name, comma, as age from student. We will run this query and this time only the first name and the age were returned to us. This query returns all the entries in my table, but it will only display the first name and the age, not the last name. Any column I specify after the select keyword will be returned to us from that table. If I want to select only the age, I will write select as age from student. I will run this query and we can see that only the ages of my students are displayed. Hello, let's do some exercises. Create and work inside the SelectDB database. For this, we will write create database SelectDB and also use SelectDB. We will select both queries and execute them. Now we can move on to the first exercise. Create the product table to store products. The products will have a numeric type ID, a name and the customer's name. Enter 5 entries in the table. Read all the product data and read just the ID and the name of the products. Pause this video and try, after which we will solve this exercise together. First of all, we will create our table. We will write create table product, and this table will have the following columns. We will have an ID of type int, primary key, auto increment. We will also have a product name of type varchar of 20 positions and the customer name of type varchar also of 20 positions. Let's create our table. We will select the query and execute it. Now we will insert 5 entries. Insert into product. We will specify only the product name and the customer name, values, and here we will have 2 texts. We will do this 5 times. We will select all our queries and execute them. Now, let's read all the product data. We already know how to do this. We will write select all from product. Now we can see all the data we have in the table. If we want to read only the ID and the name of the product, we will write select ID, comma, product name from product. By running this query, we will be able to see only the ID and the product name. Let's also drop this table. Drop table, product. Exercise 2. Create the people table to store people. People will have a numeric type ID, a name, a phone number and an email. Enter 5 entries in the table. Read all persons' data. Also, just read the people's phone numbers and emails. Pause this video and write this exercise, after which we will solve it together. We will create our table by running the query create table people, and these people will have an ID of type int primary key auto increment. We will have a person name of type varchar of 20 positions. We will have a person phone number, also a type varchar of 10 positions, and the person email of type varchar of 50 positions. We will select the query and execute them. After this, let's insert 5 entries. Insert into people. We will specify the person name, the person phone number, and the person email. Values. And here we will provide a text, and a text. We will do this also 5 times. Let's insert all these people. Now, to read all the person's data, we will write select all from people. By running this query, we will see all the data in our tables. If we want to read only the people's phone numbers and emails, we will write select person phone number, comma, person email from people. Here we will be able to see only the phone numbers and the emails. Exercise 3. Create the computer table to sort computers. Computers will have a brand, a RAM memory, a processor, and an IP. Enter 5 entries in the table, read all the computer's data, and after that, read just the brand, the RAM memory, and the computer's processor. Pause this video and try, after which we will write the queries together. Let's create our table. Create table computer, and we will have a brand of type varchar of 20 positions. We will have a RAM of type int, a processor of type varchar also of 20 positions, and we will have an IP of type varchar of 12 positions. We will create our table, and now let's insert 5 computers. Insert into computer, values, and we will provide a text, a number, a text, and again a text. We will do that 5 times. We will insert our computers in the table, and after that, let's select all the data. Select all from computer. We can see here all our computer's data. After that, we will read just the brand, the RAM, and the processor. So we will write select brand, RAM, processor from the name of our table, computer. Here we will see only the data that we need. Hello, in this video we will talk about the keyword where. When reading our entries, we have the possibility to filter the returned entries according to certain criteria. These criteria will be specified in our selection immediately after the keyword where. Suppose we have a student table with a primary key ID, a name, and an age. Let's create this table. We will write create table student, and our students, as I said, will have an ID of type int primary key auto increment. We will have a student name of type varchar of 20 position and a student age. It will be of type int. We will create our table and let's insert 5 entries. We will write insert into student. We will specify the student name and the student age, values, and here we will provide a text and a number. We will do this 5 times. Let's insert our students. We will write a select all from student query. Here we can see all our students. If my application asks me to return all the students in the table named Andrew, I will be able to run the following query. I will write select all from student where the name of my column, that is student name, equals the value I chose, and that is Andrew. Here I can see that if I run this query, I will get all my students named Andrew. I could also insert 2 more Andrews, one of 23 and one of 33. I will run these 2 queries, select again all my Andrews from the table, and now I can see that in my table I have a total of 4 Andrews. If I want to return all my students named, let's say, John, I will only have to change this value. We can see that now I have all my Johns. I will also be able to run queries in which the returned result depends on a comparison. If I want to return all my adult students from the table, I will be able to run the following query. I will write select all from student where the student age is bigger than 17. By running this query, I can see all my adult students. We can see that there is no minor here, even though in the table I have 2 entries. If I want to get all the minors, I will write select all from student where the student age is less than 18. That will bring me the 2 students that I just mentioned, John and Andrew. Also, if I want to read a single specific entry, it will be done based on the primary key, based on the unique identifier of our entry. We will be able to run select all from student where ID equals, let's say, 3. Here I can see only a specific student. Hello, let's write some exercises. Create and work inside the WhereDB database. For this, we will write create database WhereDB and also use WhereDB. We will select both queries and execute them. Let's move on to the first exercise. Create the product table to store products. The products will have a numeric type ID, a name, and the customer's name. Enter 5 entries in the table. Read all the data of the products bought by John. Pause this video and write the queries, after which we will solve this exercise together. First of all, we will create our table. Create table product, and this table will have the following columns. An ID of type int, primary key, auto increment. We will have a product name of type varchar of 20 positions and the customer name also of type varchar of 20 positions. Let's create our table. We will insert 5 entries by running the queries insert into product. We will specify the product name and the customer name, values, and here we will provide 2 texts. We will do this 5 times. We will insert 5 products together with their customers, and now let's read all the data of the products bought by John. We will write select all from product where the customer name is equal to John. We will run this query and we can see that John bought 2 products. Let's insert one more, a plain. Now, if I run this query again, I can see that John bought 3 products. Let's drop this table. Drop table product. Exercise 2. Create the people table to store people. People will have a numeric type ID, a name and a description. If a user does not specify a description, the text unspecified will be entered on that column. Enter 5 entries in the table. Read all data of people who have an unspecified description. Pause this video and solve this exercise, after which we will write the queries together. We will first create our table. Create table people, and these people will have an ID of type int, primary key, auto increment, will have a name, a person name of type varchar of 20 positions, and will have a person description. It will be a varchar of 100 characters. Now, if the user does not specify a description, the text unspecified will be entered on that column. So we will use the keyword default. Default unspecified. Now, let's enter 2 people by specifying a description and 3 by not specifying the description. Insert into people. We will specify the person name and the person description. Values, and here we will have a text and a text. We will do that 2 times. Also, we will enter 3 people by specifying only the name. Here we will provide just a text. We will do that 3 times. Now, let's shuffle a bit these queries. After that, execute them. And I have an error here because I forgot to create a table. So again, let's create a table. Only after that we will run the insert queries. And now, let's read all the data of people who have an unspecified description. So we will write select all from people. We can see that we have 5 persons. 3 of them have the description unspecified. To get only these 3 people, we will write select all from people where person description equals unspecified. Here I will have only my 3 people. Let's also drop this table. Drop table people. Let's move on to the last exercise. Create the computer table to store computers. Computers will have a brand, a RAM memory, and a processor. Enter 5 entries in the table, read all the Samsung computer data, and read all data on computers with a RAM memory less than 8. Pause this video and solve this exercise, after which we will write the queries together. We will start by creating our table. Create table computer, and we will have a brand of type varchar of 20 positions. We will have RAM of type int. We will have processor of type varchar also of 20 positions, and that is all. After creating this table, let's insert 5 computers. insert into computer, values, and here we will provide a text, a number, and a text. We will do this 5 times. We will insert this data, and now let's read all the Samsung computer data. We will write select all from computer where brand equals Samsung. We can see that we have 3 Samsung computers. Now let's read all data of computers with a RAM memory less than 8. So we will write select all from computer where RAM is less than 8. We can see that we have only 2 computers that have a RAM less than 8. The select all instruction will return us all the columns. We can also combine a where condition with a more specific select. Let's say that we want only the brand of the computers where the RAM is less than 8. By running this query, we will get only Samsung and HP. Hello, we saw that the data in a table can be inserted and read. As we will learn in this video, it can also be modified. The modification of all the data in the table is done by the keyword update. We will write update, the name of the table, then we will write the keyword set. This is followed by the name of the column whose values we want to change, equal to the new value. This query will update all the entries in our table to the value new value in the my column column. Of course, when modifying our data, we will not always want to update the respective columns for all the entries. Here comes, just like in the insert statement, the keyword where. This is followed by our condition. Also, our condition can be multiple, which means after the keyword where, we will be able to use the AND and the OR keywords, which we have already discussed in the previous videos. Let's go to Workbench and show an example. Let's create a table of students. We will write create table student, and our students will have an ID of type int, primary key, auto increment. We will have a student name of type varchar of 20 and the situation of type varchar also of 20. Let's go ahead and create this table. Now I will insert 5 students. Insert into student. I will specify the student name and the student situation, values, and here I will provide 2 texts 5 times. Let's go ahead and insert these students. Now I will write select all from student. As we can see, we have 3 passed students and 2 failed students. Let's go ahead and change the situation of all the students. We will pass them all. To do that, we will write update student, set the name of my column, student situation, equals my new value, passed. I will execute this query, and now I will select again everything from my student. As you can see, everybody passed. For you, it may not be so for now, because you probably just got an error when you try to execute this update student stat student situation passed. This is because in order to modify the data of our table, you have to run some configuration in MySQL Workbench first. And I will show you now just how to do that. You will have to go to the Edit section and press the button Preferences. Here, press on the SQL Editor option, and down below you will see this check, Save Updates. You probably have it checked right now. In order for you to delete data and update data in our tables, you have to unpress this button. you have it like this, it should be like this. Press OK. And now, if your update still doesn't work, worst case scenario, just close MySQL Workbench and start it again. After that, it will work. So as you saw, I just updated my situations for all the students. Let's say I want John to fail. I will write update student, set student situation equals failed, where the ID equals 4. By running this query, we can see that I just made John fail. If I have two students named Andrew, I will insert this entry again and read all my information. You can see I have an Andrew with ID 1 and ID 6. Both are passed, so let's make them failed. Update student set student situation equals failed, where the student name equals Andrew. As you can see, we just modified only two entries based on the name. Both Andrews now failed. Hello, let's write some exercises. Create the UpdateDB database and work inside it. For this, we will write create database UpdateDB and also use UpdateDB. We will hatch these two queries, execute them, and now we can move on to the first exercise. Create the product table to store products. The products will have a numeric type ID, a name, and a price. Enter 5 entries in the table. Change the price of all the products called pants. Pause this video and try, after which we will solve this exercise together. First of all, we will create our table. Create table product. And here we will have the following columns. An ID of type int, primary key, auto increment. We will have a product name of type varchar of 20 positions and the product price of type int. We will go ahead, create this table and insert 5 entries. We will write insert into product. We will specify the product name and the product price, values, and here we will provide a text and a number. We will do this 5 times. We will go ahead and execute these queries, and now let's change the price of all the products called pants. So we will write update product set p price equals to our new value, let's say 10,000, where the product name equals pants. By running this query, we can see that if we write select all from product, all our pants will have the price of 10,000. But what will happen if, let's say, I will enter a product called Nike pants or Adidas pants? Let's see how this goes. We will insert them and we can see that now we have some Nike pants and some Adidas pants. If we run this query again, this will not change the price of our Nike pants or Adidas pants. Take a moment to remember what keyword should you use here for this case. It's the like keyword. Update product set product price equals 10,000, where the product name is like, and here we will provide a % at the start and a % at the end. Now, let's say I want to give the value 1 to all my pants. I will run this query, and if I select everything from my product table, we can see that everything that has the word pens in the name will have the price of 1. Let's go ahead and drop this table. Drop table product. Exercise 2. Create the people table to store people. People will have a numeric type ID, a name and a profession. Enter 5 entries in the table and change the job of the person with ID 3. Pause this video and write the queries, after which we will solve this exercise together. We will first create our table. Create table people, and our people will have an ID of type int, primary key, auto-incremented. We'll have a person name of type varchar of 20 positions, and we will have a person profession of type varchar of 30 positions. Let's go ahead and create our table. Now we will insert 5 entries. Insert into people. We will specify the person name and the person profession, values, and here we will specify 2 texts. That we will do 5 times. We will go ahead and insert our people, and let's write a select all from people. We can see that the person with ID 3, Daniel, works in call center. Let's change his profession. We will write update student, set student profession equals software developer, where the ID is equal to 1. We will run this query, we will run again our select, and we can see that I actually made Sorin a software developer, not Daniel. So let's also make Daniel a software developer. Update people, set people profession, software developer, where ID equals 3. We will run this query, and now if we select everything from people again, we can see that Daniel is also a software developer now. So let's drop our table. Drop table people. The last exercise. Create the computer table to store computers. Each computer will have a brand, a RAM memory, and a processor. Enter 5 entries in the table, and after that, all Samsung, Asus, and Apple computers have been upgraded. They will have 24 RAM memory. Pause this video and solve this exercise, after which we will write the queries together. First of all, we will create our computer table. Create table computer, and our computers will have a brand of type varchar of 20 positions, will have a RAM of type int, and a processor also type varchar of 20 positions. We will execute this query and create our table, and after that let's insert 5 computers. Insert into computer, values, and here we will provide a text, an int, and a text. We will do this 5 times. We will insert our entries, and now let's write select all from computer. We can see that each one of our computers has 6 RAM. Let's give all our Samsung, Asus, and Apples an upgrade. We will write update computer, set RAM equals to 24, where the brand is in the following list: We will have here an Apple, Asus, and Samsung. We will run this query, and if we select everything for our computer table again, we can see that each one of our Asus, Samsung, and Apple computers have received an upgrade. Hello, so far we have learned how to enter data in tables, how to read it, and how to modify it. All these operations are part of a general SQL concept called CRUD operations. This is a term that you will encounter again, and it is an abbreviation for the create, read, update, and delete operations. We learned create, we learned read, we learned update, and now we will learn the last operation from CRUD, namely delete. Deleting entries from a table is done by the delete from statement, after which we specify the name of our table. This query will delete all entries in our table. If we only want to delete specific entries, we can use the keyword where followed by one or more conditions. If we want to delete all our students named Alex, we will write delete from student where name equals Alex. Let's write an example in Workbench. First, we will create our table of students. We will write create table student, and this table will have the following columns. We will have an ID int primary key auto increment. We will have a student name of type varchar of 20 positions, and we will have a student age of type int. We will select this query and execute it. Our table has been created. Now we will insert 5 elements. We will write insert into student. We will specify the student name and the student age, values, and here we will provide a text and a number. We will do this 5 times. We will insert these entries, and we can see that I actually had a typo here. I should have wrote student. We will create again, insert all these entries, and now let's run select all from student. Here we will be able to see all our students. Let's delete all the people under the age of 20. We will write delete from student where the student age is less than 20. By running this query, we can see that now in our table we have only 3 students. Our 2 minor students, student 3 and 4, were deleted. Let's say we want to delete just student 2. We will write delete from student where the ID equals 2. By running this query, we can see that now student 2 is gone. If we want to delete all our entries, we will simply write delete from student. That is all. If we run select all from student now, we can see that we have nothing here. But now, let's insert the same students again. If we run select all from student now, all our IDs will be generated from where they left off, even though we have deleted our original elements. Our IDs will not be generated again from 1. They will be generated from the last counter left in the table memory. Likewise, if we delete everything again, we will run delete from student, insert again, and now our ID will start from 11. We do this again and again, it will start from 16, and so on. The IDs will go further. The delete instruction only deletes entries. It does not delete the ID that our table has remembered. That counter will be left as the last generated value. If we want to delete all the entries and refresh everything at the same time, we have another query that we can use. Besides delete, we also have the possibility to truncate a table. we will have the truncate keyword. This keyword is used to delete absolutely all the data in our table. We will write truncate, the name of our table, student. We will run this query, we will insert again 5 students, and if we select everything from student, we can see that our IDs will now be generated from 1. This is the difference between delete and truncate. Delete from our table will only delete the table entries. Truncate will delete both the entries and the IDs from which our cursor remained. Also, using truncate, we have no possibility to add a condition where ID equals 1, let's say. We can see that we have a problem. Truncate, the name of our table, will simply refresh our table. Hello, let's write some exercises. Create the DeleteDB database and work inside it. For this, we will write create database DeleteDB and also use DeleteDB. We will select both queries, execute them, and now we can move on to the first exercise. Create the employee table to store employees. Employees will have a numeric type ID, a name, and a salary. Enter 5 entries in the table. Delete the first 2 employees. Pause this video and try, after which we will solve this exercise together. First, we will create our table. Create table employee, and our employees will have an ID of type int, primary key, auto incremented. We will have an employee name of type varchar of 20 positions and an employee salary of type int. We will go ahead and create this table, and after that let's insert 5 employees. We will write insert into employee. We will specify the employee name and the employee salary, and here we will write values and we will provide a text and a number. We will do this 5 times. We will insert our entries, and now let's write select all from employee. We can see that we have 5 employees. So let's delete the first 2. Delete from employee where ID equals 1. Also, we will duplicate this line and we will delete from employee where ID equals 2. Let's run these 2 queries, and after that let's select everything from employee. We can see that now our first 2 employees are gone. So let's drop this table. Drop table employee. Exercise 2. Create the people table to store people. People will have a numeric type ID, a name, and an email. The email must be specified. Enter 5 entries in the table. Delete all people named John. Pause this video and solve this exercise, after which we will write the queries together. We will write create table people, and these people will have an ID of type int. Primary key, auto increment, will have a person name of type varchar of 20 positions and a person email of type varchar of 50 positions. This email must also be specified, therefore we will mark it as not null. Let's also say it is unique. We will not be allowed to have the same values for an email in this table. We will create this table, and now let's insert 5 people. Insert into people we will specify the person name and the person email, values, and here we will provide two texts. We will do this 5 times. We will insert our entries, and now let's select everything from people. By running this query, we can see all our 5 persons. So let's delete all people named John. We will write delete from people where the person name is equal to John. We will execute the query, and now if we select everything from people, we can see that 2 of our people were gone because they were named John. Let's drop this table. Drop table people. Exercise 3. Create the laptop table to store laptop computers. The laptops will have a brand, a RAM memory, and a price. Enter 5 entries in the table and wipe all Samsung laptops under 12 RAM. Pause this video and write this exercise, after which we will write the queries together. We will first create our table. We will write create table laptop, and our laptops will have a brand of type varchar of 20 positions, will have a RAM of type int, and the price of type int. Let's go ahead and run this query. Now we will enter 5 laptops in our table. Insert into laptop, values, and here we will provide a text and 2 numbers. We will do this 5 times. We will insert our entries, and now let's select everything from our laptop table. We can see all our 5 laptops here. Let's go ahead and delete all Samsung laptops under 12 RAM. So, we will have here 2 conditions. We will write delete from laptop, where, first of all, the brand is equal to Samsung, and the RAM is less than 12. By running this query, we can see that 3 of our laptops were deleted. Neither one of these 3 computers met this criteria.